So we are going to reduce this feedback closed loop block diagram in order to find the transfer function that relates the output y with the reference r. So in block diagram reduction, you can use two important nodes to guide you. So a signal can be equal to another signal as the first node, and the second one is a signal can be a block times another signal. So in the process of the reduction, we'll apply these two nodes, and as you can see from this summa, E is just R minus Z, and it relates to the first node because E is a signal and R minus Z is also a signal. So a signal is equal to another signal. So you can see, applying the second node, we can see the output of this block is Z and the input is Y. So the output is just the block times the input, which gives me Z is equal to H times Y, which is equivalent or related to the second node. So substituting 2 into 1, we are going to have E is just R minus H times Y, and applying the second node again, Y is just equal to G times U. So applying the second node again, we'll have U will just be equal to C times E, and substituting 5 into 4, we'll have equation 6. So substituting 3 into 6, we'll now have our signals, two signals, Y times R, while the other component are just the blocks. So opening up the bracket, we'll have this equation, and now collecting like terms, we have Y on the left hand side and R on the left hand side. So factorizing Y in the left hand side, we'll have this, and now we'll have our Y as this. So our transfer function, which is the ratio of the output Y to the input R, which is the reference, will just be this. And in MATLAB, we can easily find this using the function feedback, and it has two arguments. So the first one is the forward path transfer function, while the second one is the feedback path transfer function. And from the block diagram, you can see that our forward path is just these two block diagrams, their multiplication, G times C, while our feedback path transfer function is just H. So let us go to MATLAB and see this implementation. So as you can see, I've already written my blocks. So the first one is just my plan, the second one is my PI controller, and the third one is my sensor transfer function. So in order to find the closed loop transfer function, I just have to use the function feedback, and then I write my forward path, which is just the multiplication of G times C, and then my feedback path transfer function, which is just H, and clicking enter, I will have my closed loop transfer function. So if you want to learn how to convert transfer function into state space, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.